Welcome everybody to this session. So I guess you can all see my screen. First, hallo und willkommen zu meiner Sitzung. Lieber, ich spreche nicht Deutsch, so I'm going to switch to English for the rest of the presentation, obviously. I can speak French too, so if you have any questions, then I will be super happy to answer them as well. Today, this session is named Java Application Containerized and Deployed Make Your Buildpack Edition. Is going to last 50 minutes. And I am very happy to have you here today with me. Let's get started. First question that comes to mind is it yet another Java and containerization talk? Well, it is, but actually it's a very lively topic. I mean, even at JCON yesterday, there was a very good presentation from Matthias Oessler about the same topic, but there is so many aspects to it. Of course, during this session today, we'll discover the different options available in 2021. Then we'll see the pros and cons of the different approaches. We'll focus on Buildpacks, definitely the Cloud Native Computing Foundation Buildpacks, CNCF Buildpacks, how to create them and how to use them. But before, please let me introduce myself. My name is Anthony Dahanne, and I am a Java developer and cloud architect and DevOps guy. So I'm pretty much involved with development and deployment, definitely. Also, I would like to say that I am one of the leaders of the Montreal Java user group, because, hey, I am from Montreal, and actually I'm currently in Montreal right now, today in Canada. The Montreal Java user group, just like any other user group, hosts a meeting every month or so. Then we got the sister organization of Montreal Java user group, which I am a member as well, that is named Devox for Kids, where we focus on creating workshops for children aged from 5 to 14, for example. Unfortunately, due to the pandemic, we haven't been really active those recent months, but there is hope for a quick return. Finally, I'm also a member of the Cloud Native Eastern Canada meetup. So it's just like a Java user group, but we talk about CNCF technologies such as Kubernetes, Helm, Prometheus, and Buildpacks, actually. So enough about me. Let's go through the agenda. Today, we will, of course, do a quick recap about what containers are. Then we'll move on to the typical options that we have, that we had for quite a long time, actually now for a few years already, the Dockerfile and Google Jib. Then we'll move on to the Buildpacks, and we'll have a look at actually how do they work, what are the concepts behind the Buildpacks. Then we'll move on to actually using the Buildpacks and customizing them for our own needs, because you don't necessarily need to create your own Buildpack. You can actually piggyback on the existing Buildpacks. We'll see that. And then finally, we'll see how well the Buildpacks integrate with existing CI and CD environments. So let's go through a quick intro about containers. So what I like to say about containers is that a container is a bunch of layers of file system layer on top of the host kernel. And if you look at the picture on the right side of my screen, you'll see that the most important thing is, of course, the kernel from the host OS, but this is not part of your container, right? Your container is just going to reuse that. So this is where the isolation stops, right? Because a container doesn't bring its own kernel. What it does bring, though, is actually file systems such as the base image. So the base image in case of Debian will come with /etc/var and so on and so forth. And also some libraries and tools, of course, which make Debian Debian. Then the user will be able to inherit from this base image and will be able to actually add a JVM, add its own application, probably packaged in a jar, and then add some metadata such as which should be the user to run the process, root or someone else. And then finally, an entry point that will allow the container executor to understand what should be the command to run when the container is started. But this is not only about containerization is not only about file system and metadata, it's also about isolation. So I quickly said that we are not isolated from the kernel of the host OS, but we are isolated through other means. So the most important, of course, are chroot namespaces and C groups. Namespaces, they limit what you can see, such as the different processes on the network, on the file system, the unique timestamp, and so on and so forth. And C groups are also super important because they will limit what your process can use in terms of memory. So you can bind the available, you can limit the available memory to 1 GB to your container, for example, to your process running in your container. You can also limit CPU, IO, and network. What we commonly say is that a container is an instantiation of an image, and the image is the template, right? Also, we often talk about Docker images, but now there is a spec. It has been on for a long time. That is the Open Container Initiative, OCI, and Docker images and OCI images are kind of the same. There are not many differences right now, but you will hear me talk about images more generically. It can be either of those. Actually, tools, they support both. Let's move on to containerizing Java using a Dockerfile. It has been on for a few years already, since at least 2014. Java developers at that time, they were all using Docker files, and they would define here, for example, a base image using the from keyword. Then they would copy their jar, and then they would expose a port, for example, 8080, if it's the default port that your Java process is going to listen to, and then define an entry point, such as java-jar app-runner.jar. That's fine. Pretty obvious. Pretty standard. It has been here for a while already. And then Docker introduced in 2017 the multi-stage build that allowed developers to actually separate their build instructions from the run instructions. For example, here in the second part, we are going to use OpenJDK as build, and we're going to run our Maven build in this image that is named as build. But then for the runtime image, the image that is going to run in production, we can start from another base image and actually just copy directly the jar that we built previously. So from the production image point of view, the only thing that we can see is the base image, then the jar. We don't see all the process of, well, we don't see anything else, basically. And what I like to do at this point right now is basically show a demo of how those work. So let's have a look. By the way, this demo is available on GitHub. So what I'm going to do right now is paste you in the chat the URL. And if I know how to copy paste. Okay, yes, it's in the chat now. So just feel free to have a look directly in the chat. Yeah, you have a link in the chat, so you can follow along. Anyways, let's go to this project and start actually having a look at the Docker files that we have here. So we have, this is for the base use case, where you just have a Docker file, and then you actually build, it's kind of the usual way. So the way you do that is that you do your Maven build, and after you do your Maven build, you will package your jar into a Docker image. So this is a very common operation to do. Okay. Of course, I run that previously, so it was super fast thanks to the Docker caching. Okay, fair enough. Now, in the second example that I had, where you have a multi-build, once again, yeah, you've got the builder configuration, and then you just copy from the builder what you need to do. So here, the main difference between well, with previously is that actually the the Maven operation is not going to run on my machine. Well, on my laptop directly, it will run directly from inside the container. So the Maven build will run from inside container, and that can be quite interesting because if I don't have any tooling on my machine, then, well, there you are. It can be pretty nice to do this. Then you can actually, of course, run the application. So what do we expect from this application? Not much. Just we hit a REST endpoint, and then we shall see bonjour monde. So I guess that's nothing really special. Okay, let's have a look. Bonjour monde. Okay, this is as expected. Everything is fine. That was it for Docker files and Docker builds. What are the plus? Of course, Dockerfile familiarity. Once again, it has been here for a long time. It works with all stacks because at the end of the day, with Docker daemon and Docker files, we don't really care about what you're doing, if you're doing Java, Node, etc. Then on the minus side, on the con side, it might require a Docker daemon, and you should, and sometimes you would need to run this as a root user. There are some alternatives though today. For example, if you're using a builder such as Keine, it doesn't require root access. But anyways, it has been at least a problem for a long time. And also, it is not leveraging stack specificity at all. Of course, so since it's versatile, then the problem is that it doesn't really understand what's going on. So it cannot actually fine tune your image because it has no clue what a Java project looks like. So there is not, there is no fine tuning at all. Let's move on to Jib. It came later. It was created in 2018 by the Google Cloud Platform team. And this tool is super interesting because it is written in Java completely. The only thing that you need to run Jib is a JVM. And what they did actually is that they implemented the OCI specification, Open Container Initiative specification, to actually build the image directly, the images directly from Java. One nice thing is that it's Dockerless in the sense that it doesn't need a Docker daemon to run, since it only requires a JVM, right? And also it's Dockerfile-less. So this is a choice that we did, saying that, well, we don't need to support the Dockerfile because we're just about Java processes. We just want you to, put your classes in SRC main and put your resources in SRC main resources and so on and so forth, and we'll do the rest. So this is pretty convenient. One nice feature from Jib is that from day one, they supported reproducible builds. So what did they do? How did they do this? Well, just simply, they just stripped metadata such as timestamps. So this is why you often see, if you look closely at the layers of a Jib produced image, you will see that some layers are 51 years old. It's because they just removed the timestamp. And thanks to that, the cache will be much more efficient, right? Because whenever you rebuild the same project, then the layer won't change at all. Otherwise, if they kept the timestamp, then they would need to recreate the layer just because of that, and then you would lose cache and so on and so forth. One also nice feature from Jib is that they choose to use a Java a special layering approach. So let's look at the picture here on the right. As you can see, once again, we're defining our container image on top of a kernel. That's fine. This is an inherited. Well, it's given to us by the host OS. Then same thing, Jib is going to use a base image. They used to use distroless, but now I think like 4 or 6 months ago, they decided to choose by default adopt OpenJDK since version 3. It's pretty recent. Anyways, you can still override the base image if you want to. Then on top of the base image, of course, if the base image doesn't include a JVM, they will add it, but usually the base image comes with a JVM. Then as you can see with the 4 green layers, you can see that for each type of resources, they will add a layer. So they will add a layer for the dependent jars, for the dependency jars inside /app/libs. Then for all the resources that you have under SRC main resources, they will have a special layer for that. Then for all your classes that are compiled, they will have a special layer for that. And finally, if you have anything particular, such as CA certificates, they will also have a special layer for everything else, basically. Thanks to that, if in your project you rebuild, if you rebuild your project and you only change some classes, all the other layers won't be rebuilt. And this is what's so smart about Jib, is that it understands the structure of a Java project. Let's go through an example via another demo. So let's kill that for now, and let's move on to the Jib folder. Now, if we go to Jib, since we don't have Docker files, we don't have any Docker files anymore, what we're going to look at is the POM, okay? And inside my POM here, I am using the Jib Maven plugin. Actually, it's funny because if you're doing a quick build, you don't actually need to upgrade your POM. You just directly can invoke it from Maven. You can say Maven Jib build, for example. But anyway, here I wanted to configure it a little bit more. Here I decided to choose another base image, so OpenJDK 17, because my project seems to be a Java 17 based project. Then I decided also to give the coordinates of my image, because Jib can actually build and push the images. And also I decided to to override my Java tool options, my JVM arguments, when I start the build with a custom CA certificate. So why should I do this? Well, because I wanted to have an example that is close to what people do from inside enterprises, and oftentimes you need to deal with custom CA certificates. Here in this example, I'm connecting to this website of mine, and this website has its own SSL cert. I mean, it has its own public cert, and this is why I needed to include under my Jib folder my own thruster. So basically, I am running my JVM with a custom thruster. So let's have a look at how it works. I mean, how it builds. As simple as Maven W compile Jib build, and then we'll have a look at what's going on. Okay, it seems to be already pushing. All right, it's already done. And also it was nice enough to tell me that the entry point was set to this. So basically it's going to start directly from my class, because remember, it's not starting java-jar, right? Because it has split everything into different layers. So actually we can have a look at this. It's often interesting to see how it's being organized. So if you look at the history, you will see, you remember those 5 different layers where you have your dependencies, resources, classes, arc files, extra files. Okay. Of course, let's run it. So what this application is going to do, when it's going to start up, it will it will actually connect to this website of mine. And since it's running with a right thruster, there is no issue. It was able to load the page successfully. Also, it exposes port 8080 with Bonjour Monde once again. Okay, cool. That's it for Jib. What about the plus and cons, the pros and cons of using Jib? Well, obviously, the first pro is that it's super fast thanks to the smart layer caching. Okay. And also, you don't need an external tool such as the Docker daemon. This is a huge plus. You just need a JVM, so it can be super efficient to actually run your build from on CI on a machine on a runner that doesn't have a Docker daemon, for example. On the con side, it's specific to Java apps, even though they have a Jib CLI that is coming up. So maybe that's going to change, but for now, it's really specific to Java apps. I mean, when I'm talking Java, by the way, it's JVM, right? So it can be a Kotlin, Scala, and Java, of course. Also, there is a limited reusability of the configuration. Why? Because most of the configuration you put is inside your pom.xml. So if you wanted to share it with other projects, for example, you will need maybe to put it inside a parent POM or something like that. So, and also if you have some other projects in your organization where you're building Node.js apps, Rust apps, Go apps, and whatnot, you won't be able to reuse anything that Java has done for you. It's finally time to talk about Buildpacks. So let's have a look at what they are. Actually, they're pretty old, right? They've been around since 2012 in Heroku and Cloud Foundry. Maybe you remember the time where, so Heroku is a PaaS, platform as a service. And when you used Heroku, you just needed to basically do a git push to Heroku, and then Heroku would detect what type of project it is. So if it's a project with a pom.xml, it would understand that it needs to run a Maven build, and then, well, detect, build, and then run the image on their infrastructure. And the cool thing is that in 2018, they were, so Heroku and Cloud Foundry submitted the Buildpacks to the CNCF. So it started as a sandbox. This is the entry level when a project joins the CNCF. And then thanks to different contributions and also different organizations running it in production, it has been graduated to CNCF incubation last year only. Just 1 year ago, November 2020. So what are Buildpacks? Basically, they define a spec and the combination of several concepts. The most important ones are the lifecycle. For example, when it decides to detect and then it decides to build and to create the image. The builders are basically the brain of the Buildpacks because they decide what are the Buildpacks involved and what they should do and when. And the stacks basically define the base images for the build and the run image. The default implementation of the Buildpacks is the pack CLI. You can install it from, well, using Brew, for example, on macOS. And of course, it's supported on Linux, Windows, and macOS. But there are many other ones, and we'll talk about that a little bit later in the presentation. Let's go back to the different concepts through a schema. I will start talking about the stacks. In a stack, you've got two images. You've got the build image and the run image. The build image, as its name implies, will be the image, the base image that is going to be used by the Buildpack when it's building your image. And the run image is the base image of your final application. The Buildpacks here, in my example, in this schema, I've got three different Buildpack, Buildpack A, Buildpack B, and Buildpack C. Each of them is implementing bin/detect and bin/build. They can be binaries or they can be simple bash scripts, actually. Also, each Buildpack has a TOML metadata file where there is information about the Buildpack and what is the stack it is using. In bin/detect, the Buildpack will detect if it can participate in the build, if it's something it knows how to do. If it's a Java Buildpack and there is no pom.xml or no Gradle file, it will normally just say, I'm out. I'm not going to do anything. But if there is a pom, most probably then in the bin/build script or binary, it will actually call Maven. And finally, you've got the builders, and the builders, they are actually gluing all those concepts together. When you start the pack CLI, the first thing it's going to do is retrieve a builder. So it can be a default builder or a builder that you specified. And then the builder will basically call the build pack successively to understand what it can do with your project. So if your builder supports Java, Node, Go, Ruby, and so on and so forth, if it finds a package.json file, it will decide to use the build pack. I mean, the build pack that is building Node will actually say, hey, I can do something with this build. Of course, let's see this through a demo. This demo will be about creating my own build pack, basically. So where do you start when you do such a thing? You remember, you just start with a stack. So here I have a stack named Anthony because I'm not super creative with naming, unfortunately. So in this folder, I've got a base folder that defines a Docker file. In this Docker file that is based on Debian, I have installed some tooling, some common tooling that will be used by my build image and by my base build image and my base run image. That's basically it. Then in my build image, I am inheriting from this base image. And then I am adding some more tooling such as git and wget. Probably I will be using them. And then finally, in my run image, I'm not doing anything else. I'm just inheriting from the base image actually. So maybe I could have simplified this structure. What I can do with those is that I can actually go to this folder and start building those. That should be pretty quick. So basically here I'm building my stack. The interesting part of it is, as you can see, there is a stack ID argument that is given. And this stack ID argument will basically, of course, define my stack. So when I'm going to create my build packs, I will need, of course, to reference this stack ID if I want my build packs to be compatible with this stack. Cool. So I am done building the Anthony stack. Let's move on to the build packs. What do I have in store for you today? I've got Hello Anthony. The first thing that you want to see in a build pack is bin/detect. Let's have a look. What does it do? So this build pack is very special because it returns status code that is different than 0. It means that this build pack will never participate in anything. It will always say during the detect phase, I'm out. I'm not doing anything because it returns something different than 0. So it's not super interesting, but of course, it's a nice example. There's also metadata in this build pack, such as the Buildpack API version. It is changing quite frequently, actually. Then I define the ID, the version, some metadata, and of course, the stack ID. Let's move on to the second build pack that I have. Let's go to the detect phase. This one, at least, is not returning a fixed error. So basically, it's returning, since it's not returning anything, it's a success, it's 0. It means that it will be able to participate in any build. Let's have a look at what it does during the build phase. During the build phase, it will basically display some text, and then it will define a process that is basically the entry point of my image. And in this entry point, we can see that it will just display some text. So it's not super useful, this build pack, but at least it does something. It participates in creating an entry point with a fixed text. Why not? Let's move on to a third build pack that is a little bit more interesting. It's named single HTML page. Let's have a look at detect. And in detect, we can see that it will only return a success if it found an HTML file. Okay, so what that means is that it seems to be interested in HTML files. So what is it going to do with it when it's going to build the project? Well, apparently it's fetching something on the internet. Oh, that is socket. And it's going to use socket to actually open the 8080 port and pipe the content of the HTML file to the port 8080, basically. So it's a web server. It's definitely a web server, a very curious one, but still it's going to serve the HTML content. So those build pack, I could actually package them, but just to save some time, I won't do it. But as you can see, the pack CLI knows how to actually create a build pack. So you just tell the pack CLI to you use the build pack package command, and then is going to read the toml configuration and then be able also to publish it. Actually, I can just, maybe I can just create the first one. If I am in the right directory, yeah. Okay, build pack package, and then it's going to simply package it and publish it. Okay, but let's move on to the glue, the builder. So here I have an Anthony builder, and the builder is going to define all the build packs that it will be able to use. So here I have Hello Anthony after, and simple web. That is my for HTTP server. One important thing in my builder is the order used for detection, because according to that, it will define what is the most important thing to do. So here, the most important thing to do is find HTML file. But if you cannot find any, if you return something different than 0, then you will, successively go to the other builders. In a builder, you also redefine the stack that you're going to use. Okay, and you remember I've already built my own stack. So let's go to this builder folder, and actually let's use, once again we're going to use pack builder create this time to actually create my builder. Okay, puff. And when my builder will be created, I will finally be able to build images with pack actually. So here I will be using this command line to create an image. And what I suggest to do first is actually test my builder. So create a test image, or maybe, you know what, I'm just, test is a bit confusing for a name. I'm going to call it JCON. So let's test my builder in this folder, right? So I am inside this folder named Anthony. There is only a README and a builder.toml. So since there is no HTML files, there is a high chance that my build pack of my web server build pack is not going to contribute. So as you can see here, during the detecting phase, the HTML build pack did not participate. Then Hello Anthony returned an error. That was expected because this is the only thing it does. And finally, Hello Anthony after decided to do something. And as you remember, it only displays some text. So actually, let's test this out. Let's test the image that I just produced. Yeah, it's just displaying salut after. But the cool thing with this builder is that if I am in another folder, in a folder that contains some HTML code, then it's going to be a different story, as you could expect, right? So if I move on there, and then I'm exactly running, I'm just invoking the builder exactly the same way, pack build JCON using my builder, then of course it will find out that there is something interesting for the web simple HTML build pack. And then, as you can see, during the detection phase, the simple web build pack decided to participate. So it downloaded socket, and then it created my image. And most probably, if I run this new container, there is a high chance of having this socket serving on port 8080. Yeah, welcome to simple HTML app. I guess it was the content of my HTML file. Okay, good. So this is interesting, right? Because the builder is not going to react exactly the same according to the context. And it means that you can use the same builder for many different types of projects. They can be Node, Ruby, and Java, and so on and so forth. So it's pretty interesting with the same command line to build any types of projects. But as you could see, it was kind of complex, I have to admit, to create my own builder and build packs. So what we're going to see next is, are there any build packs available to you as of today? And of course, the answer is yes. You can piggyback on existing build packs, and you may actually choose a different JVM vendor or version. If you, for example, if you pick a given build pack, maybe by default it's going to use the Azul JDK. Maybe you want to force it to use another one. Maybe it's going to use Java 11 to compile. Maybe you want Java 17. So at least you can, pass some configuration to your builder. You may also, of course, want to include a CS certificate and also give some settings.xml to Maven. Now I'm going to focus on Paketo. Paketo build packs, where do they come from? Actually, they're coming from Pivotal VMware, and that kind of makes sense because, because they're actually pushing the build pack, the pack specification. And the cool thing is that Paketo build packs are natively integrated into Spring. So this is what we're going to see when you have a Spring Boot application and you're using build packs to build. By default, they would choose to use the Paketo build packs. Let's have an example through a demo. First, one thing that could be interesting to see is there is a command line that is named inspect, right? So, of course, so if you ask pack, if you ask for help to pack, you can see the different commands that are available. And let's have a look at the pack builder. Pack builder, help. And here you can actually have suggestions from pack. So let's have a look. Pack builder suggest. What this thing does is that it's going to display what are the default builders that are coming with the pack CLI. And you will see that there are only 3 of them. Basically, one provided by Google, one provided by Heroku, actually 2 provided by Heroku, and 3 provided by Paketo. We will focus once again on Paketo from now on. And let's go to a Java project that is once again the same, but this time we will use Buildpacks to build this project. The first thing that we could do actually with this Spring project is build it with the pack CLI. Here, I'm going to build it and I'm going to specify a Paketo Buildpack builder, as you can see here. And also, I am going to provide some options, some customization to pack. So let's have a look. Here I am basically providing platform bindings and also specifying the JVM version. So here I'm going to force pack. Actually, I'm going to tell my builder that I want it to use a build pack that supports Java 17. Of course, everything is documented on the Paketo Buildpack website. So yeah, there is nothing hidden. So now, as you can see, the build has started, but the first cool thing to notice, of course, is the detection phase, right? And as you can see here, it will, out of 16 build packs, 7 are going to participate in my build. So this is kind of, a game of Lego when you think about it, right? Because each build pack can add something to the other one. One build pack is coming with Maven, one build pack is coming with a JVM, one build pack knows how to handle custom certificates, because here, this is what I have in my binding folder. I have my own certificate, CSR, because you remember that my project needs to connect to a website that needs its own CSR. And did it succeed? I guess so. So yes, as you can see here, we got a Java 17 and proof. It started the build. and then everything worked fine. Let's have a look. Dash P, sorry. Tung. Aïe, aïe, aïe. Ctrl-C, Ctrl-V. Wow, copy pasting during live demos. Sorry about this. All right. Let's start this container that was built using Buildpacks. And as you can see, well, it seems fine. It's running Java 17 as I expected. And hopefully see, I don't have any errors while connecting to my self-signed web server. Everything is working fine. Of course, if I go to 8080, I still have Bonjour Monde. Cool. But you don't need, you don't need to use the pack CLI. You don't even need to install the pack CLI. Why? Because Spring Boot, they done an amazing work during the 2 last years of actually implementing the pack specification, because I told you that pack CLI is the default tool, but you can actually re-implement it if you want. And this is exactly what they did. And the cool news is that in Spring Boot, it's by default. Whenever you're using the Spring Boot Maven plugin now, it's supported. It knows how to handle even the bindings of your custom certificates. And also you can override the different build packs if you want to. You can override the builder. You can give environment variable to configure the build pack, and so on and so forth. And how would you use it actually? Well, it's pretty simple, right? You would just use your Maven command. Maven Spring Boot build image skip tests. So yeah, you would just run it exactly as usual, just Maven command, and then you would be able to actually run to build your image from Maven. So that's pretty cool. Let's go back to the presentation. I have only 8 minutes left. That should be good. That should be good. Buildpack Spring Boot integration, I just talked about it. Naturally, default build packs are Paketo build packs because Spring belongs to Pivotal, that belongs to VMware, and actually Paketo build packs the same. There is also, if you were asking yourself, does it support native images? Well, it does actually. You can actually just with setting this environment variable, you can say that you want to produce a native image. And bindings, they're actually working. So if you want to bring your own CSR, you can. This is exactly what I did during my demo. It was not the case 6 months ago. We still had issues opened, but we closed them. So good work on the Spring Boot team. There are other integrations than Spring Boot. There is Waypoint from HashiCorp. The GitHub Actions also, they support Buildpacks. Circle CI supports Buildpack. Tekton, the cloud native build tool, is supporting Buildpack. Scaffold, Kpack from VMware Tanzu knows how to handle Buildpacks, of course. Then the platform as a service, Heroku, Cloud Foundry, yeah, of course, they invented it. Google Cloud also, they are kind of fans of Buildpacks because whenever they have a new tooling on the Google Cloud platform, they actually support Buildpacks. And other CI tools. I have a little bit of time remaining, and I wanted to say something first before diving into into another demo about deployment. I want to say that one very nice thing with Buildpacks is that there is the rebase command. What is the rebase command? It means that you can basically swap the base image. Imagine that there was a critical issue in your base image. For example, your base image was Debian, and there was a critical SSL issue or something like that. I mean, it happened, right? Then the cool thing is that you don't need to rebuild all your project. You can just swap out and swap in a new base image directly into your image. So you can reproduce, you can recreate your image, you can patch your image basically without having to do the full rebuild. So this is kind of this can be pretty neat. I think it's a very strong feature of the Buildpack ecosystem. Now moving on to the demo, what I would like to talk about, what I'm going to show is basically the GitHub, the GitHub action deployment. So of course, once you have created your image, you will want to actually run it, right? So here I have a GitHub action defined. So the first thing that I'm doing is check out, and then I am installing the support for pack, for Buildpacks. And here, look at what I'm doing. Basically, I am giving credentials to GitHub. I mean, I'm giving my Docker IO credentials to GitHub. Fine. Then I'm going to this folder, C Buildpacks, and from there, I will actually build my project using the pack CLI that has been provided to me by the setup pack. Once this is done, I actually decided to add a deployment step where here I am using fly.io to actually deploy it to Fly. So let's have a look at what it looks like. Here, if I'm going to my repo, if I go to actions, if I look at the last build, let's see the detail. As you can see, run build pack, run pack, build and publish. So let's have a look. Of course, it's a pretty lengthy step, right? Because it was downloading all the different build packs. Then, as you can see, it was running the Maven build, blah, blah, blah. Okay, and after that, we can see that the build pack was in action and was actually using Paketo buildpack to approach my, my image. And then finally, it was deploying it here on fly.io. If I go to my admin interface, I should see normally my app. Bonjour monde, hello world. Sorry for the French, but anyway, yeah. So yeah, I have actually a continuous pipeline, and yeah, the way that I could do actually is that, of course, I could build a change, and after it's committed and pushed, you would of course see the change. Display automatically, probably. Come on, IntelliJ, yeah, you push, that's fine. And then of course it's going to trigger a new build. Well, this is the way GitHub action works, and of course it's going to republish everything. Let's make sure of this. Dong actions. Java version. Ooh, and now it's going to deploy. We have 2 minutes for questions. Please shoot. I haven't looked at the chat so much, but if you have any questions, or if the moderator wants to help me pick up question on the chat. No, I just have a reminder. No question? Nobody has any question for me? No? We still have 1 minute before it deploys the German version. Okay, if you don't have any questions, let me ask you this question. I mean, this is me. I'm going to ask you the question. Are Buildpacks the right tool for you? You know what? If you're familiar with Docker files and you're okay with them, you're not suffering at all, keep on using them, right? I don't want to tell you that it's going to change the whole world. Just, you know, you can still keep on using them. If you want something easy to use, super fast, and you only build Java in your company, Jib is super good. I mean, that's definitely the simplest option, fastest option. Now, if you have several teams of developers to deliver complex images with certificates, agents, and you've got different stacks and tools involved, you've got some Node.js project, Python, Java, and so on and so forth, then yes, I think Buildpacks are definitely solving this problem, because you can define a builder for your company or just piggyback on Paketo and then cover all the different use cases. I thank you for listening. I hope the German version is deployed. It shouldn't be too long now. And once again, if you have other questions, feel free, or you can reach me out on Twitter and whatnot. Oh, see, whoops, the German version was deployed. We'll end up with hello, Wellent. I'm done. Thank you very much for watching.